Welcome back. We've got one last little idea around adaptations to think about, and it's called biomimicry. So it's a strange connection in some ways. Essentially, biomimicry is when we take an idea from nature and use it to create some sort of process that allows us to overcome something. And one of the classic earliest examples is Velcro. So this guy in Switzerland was out bushwalking, happened to be a bit of a scientist, technologist himself anyway, and he got, like most of us, got pretty sick and tired of all those burrs get stuck in our socks. We have bidgie widgie in Victoria, well, in Australia generally, and those bidgie widgie rely on their seeds getting stuck in your socks to get spread around, well, getting stuck in fur to get spread around. And this guy thought, oh, I could make a really strong connector with that, for clothing. And clothing was his first attempt. And so he created Velcro from the experience of working with bidgie widgie. I think, interesting. There's a wonderful story about a guy who created a building in Harare in Zimbabwe, which is a very hot, humid climate, and he used his knowledge of ant nests, termite nests, and the termites change direction of airflow through their nest all day long. So he created a building that used airflow through the building from outside to cool it. And the building basically stays at about 20 to 22 degrees Celsius, 24 hours a day, 365 days a year, without any air conditioning or heating inside it. Very fascinating. He actually was the guy they brought in to look at G2 in Melbourne for their government building. Anyway, there's a whole lot of examples. One of the interesting ones is the bullet train. One of the problems with the bullet train was that as they come through tunnels, particularly, they create a sonic boom and it sort of upset the locals. So they went trying to find a way of reducing that sonic boom. And some of these engineers who were working with it were aware of how the kingfisher fished, and they create really small splash when they hit the water and grab a fish. I thought, I wonder if that's going to work for us. They designed the bullet trains, there's a Chinese one, so they're really long and narrow at the front. And not only did they actually remove the sonic boom, reduced it, but they made it more efficient. They're actually using 15% less electricity to operate the thing, and they're running 10% faster because of this shape change in the front. So pretty clever and pretty effective. Geckos' feet are always one of those really interesting things that have caused a whole lot of inspiration, because these guys, of course, can walk up walls, walk up glass. Amazing amount of adhesion between their toes and the surface they're walking on. So a lot of climbing gear now is based around what we've learnt about looking at the surface of the gecko's toe. So a great little example. The lotus flower is an interesting one. The lotus flower is a water flower, a water-based plant, and it opens and flowers through the surface of the water, but they remain dry. And they've discovered they've got this really interesting water repellent qualities that engineers have copied and created all sorts of different uses on tools and surfaces in homes and hospitals, where things don't stick, they can just wash off really easily. So it's quite a clever idea. I think that's my last slide, isn't it? Yeah, this is just really to introduce that idea of biomimicry. It's not a hard one, but the things we're copying, of course, are adaptations by plants and animals that allow them to survive and achieve certain things. So it's a little variation on adaptations to finish our week off. And next week we'll have a look at homeostasis and a few other things.